All right, thanks, Paul, for the introduction, and good afternoon, everybody. Today I will present to you our work on temporal measurement of malicious apps on Android. This is joint work with people at Norton LifeLock, Shen and Pierre-Antoine Vervier. So when we think about malicious Android apps, there are many bad things that apps can do. And Google actually have a fairly detailed taxonomy of what malicious apps can be doing. So we have malware, mobile malware, which is, they are the apps that do very bad things. So they do phishing, ransomware, spyware, and all these kind of things. And then we have all these apps that sort of fall in between in this gray zone, which are called mobile unwanted software, and they do things like displaying annoying ads, trying to collect personal data and things like that. All of these apps fall under an umbrella which is called potentially harmful apps, or PHAs. So this is what we are studying in this work. Now, the research community, the security community, has been studying the problem of malicious apps on Android for a while. And to do that, they've been following three main research directions. So the first one is looking at app markets, so crawling apps from app markets, and performing analysis on the apps downloaded and so on the metadata from the markets, and so on and so forth. This gives us an overview of what's going on to some extent, but it misses a piece. So we do not see what happens once apps are installed on devices, how long do they stay on devices, what do users do once malicious apps make it on their devices, and so on and so forth. The second category had users actually install an app on their own phones, so these are research participants. And then these apps would collect data about malicious apps running on those devices. Now, the challenge there is to recruit a large enough group of people that makes it representative. And finally, the third category looked at network traffic from mobile ISPs. So we are not looking at markets anymore, we are not looking at devices anymore, but we are sitting somewhere in between, looking for traffic that we consider malicious. And the issue there is that to identify what is malicious, we need to rely on block lists and lists of known malicious domains, IPs, and so on, which we know very well that they can be limited and incomplete. So all this research leaves many open research questions. So first of all, we don't know how long mobile devices stay infected with these PHAs. So once a malicious app makes it on your phone, do you delete it right away? Does it stay there for years? We don't know. Similarly, we don't know how long PHAs persist on Android marketplaces. And this is made even more tricky by the fact that there are many marketplaces. Obviously, Google Play is the biggest one, but there are many others that are vendor-specific or third-party marketplaces and so on. Also, do these PHAs migrate? Once they get removed from one marketplace, do they move to another one to stay active? And what are these dynamics? And ultimately, what are the implications for Android malware research in general that we can make by answering these questions? So what we did, as I said, this was a collaboration with Norton LifeLock. So they have a mobile anti-malware product. So we actually had this product installed on user mobile phones. And what they do, they have this whole infrastructure. They analyze apps, they identify malicious apps, they build signatures, and then they ship the signatures to the devices. And then the devices have this app that runs periodically, identifying all the malicious apps that are present on the device. And then they warn the user about them. So we would collect all this metadata from millions of devices around the world to get a global view of what's the status of Android PHAs and answer all those research questions. And then on top of that, we take this telemetry and we run it through VirusTotal to get a more comprehensive set of malware signatures that may go beyond the biases of the one antivirus company that we were working with. And we also use AV class, which is this ML-based system that takes virus total reports and gives you basically one label, one malware family for each app. So we ran a data collection for a year between 2019 and 2020. We had a population of over 11 million devices around the world, and we collected 3.2 billion events. So these are detections of malicious apps on these devices. And these amount for 8.8 million unique SHA-2s, so unique malicious apps. So the paper is very dense, so we have a lot of results, a lot of measurements, but what I'm going to do is giving you some highlights of our main results and our main takeaways. So how long do PHAs persist on devices? Well, mobile antivirus products are actually limited in what they can do by the Android security system, the Android permission system. So they cannot delete apps themselves directly. So the only thing they can do, they can tell users, I found these apps, please delete them. Okay? And what we found is that users do not promptly delete these apps. So for malware, we find that these apps stay on the device for more than 20 days on average after being detected, so after the user was warned. And for the mobile unwanted software, it's a little less, 13 days. And this might be because these apps tend to be more annoying. They will display annoying ads or do weird things, while the malware might try to stay stealthier. When looking at in-market persistence, so when we see a detection, oftentimes it has metadata that tells us which app initiated that download. So we can see which apps were downloaded from Google Play, from Huawei market, or however many markets are out there. And so if we see 2 detections after a certain amount of time for the same malicious app coming from the same marketplace, we can use that as a lower bound for how long was the PHA alive on that marketplace. And so we find that actually PHAs persist on marketplaces for several weeks. So for example, for Google Play Store, they stay on for 77 days on average, and for Samsung Market, they stay on for 56 days on average. I have to say that actually, Google Play Store, for example, they do a lot of detections before the fact, so many apps don't even make it to the market. Most apps, probably, but those that do stay there for a while, which is troublesome. And then finally, we look at migration. So we find that PHAs migrate from popular marketplaces, let's say Google Play Store. After they get removed, they migrate to smaller marketplaces to keep operating. But we also see the opposite. So we see malicious apps that are first uploaded on smaller marketplaces, and then after a while, they make their way to the most popular ones. And why? Because that way they can reach more victims. So we can measure how many victims they reach, at least within our set of 11 million devices. And we can see that by migrating to larger marketplaces like Google Play and Huawei Market, they can reach up to 50% more victims. So what does this mean for Android malware research? So this is kind of showing a quite negative picture of what's going on out there. Apps stay on devices for a while, so we're doing something wrong there. Apps stay on marketplaces for a while, so we're doing something wrong there as well. Well, first of all, there is this limitation of Android mobile malware tools that they cannot delete these apps. And one thing that could be done is actually studying why people actually install an anti-malware product in the first place, but then they don't listen to what the anti-malware product is telling them. Maybe there is an interesting research direction there for people in usable security on developing better nudges, better warnings, and things like that. And from the marketplace point of view, it looks like marketplaces are not really talking to each other when it comes to malicious apps. So if an app is removed from one marketplace, it then pops up on another one, while sharing this type of intelligence and previous detections could actually help getting rid of these apps, or at least raising the bar for malicious users. And yeah, as I said, there are many more results and many more measurements in the paper, so please go and read it. But this is what I wanted to tell you about today. And thanks, and I'm open to questions.